Solving system of linear equations, solved by graphing. Welcome to Mark's Math Methods. So how do I solve a system of linear equations by graphing? Draw each line individually, one at a time. Example, here's a system. Y equals 2x minus 1 and y equals negative x plus 2. So I want to graph each line individually. But first, how do I graph a line? If you don't remember, we'll go by it. We'll brush. There are two basic formats for linear equations: slope-intercept form, y equals mx plus b, and standard form, ax plus by equals c. Let's look at slope-intercept form. B is the y-intercept, 0, b. M is the slope, or directions. So here's an equation, y equals 4/7 x minus 3. The y-intercept, the b, is where we start. So we're going to start at negative 3 on the y-axis. The 4/7 are our directions. Rise up 4, overrun 7 to the right. Boom, done. So the slope, best seen as a fraction, is rise over run. How many go up, and then how many you go over. Positive is up, and to the right is positive. Down would be negative, and to the left would be negative. And they're continuous directions. So from that second point, I could still go up 4, 7 to the right. I get another point on the same line. So if it already says y equals something, then we can graph using slope-intercept form. Standard form. Ax plus by equals c. Here's an example of a problem. 2x plus 3y equals 12. We're going to make an xy table, and we're going to plug zeros in for the x, and then another 0 in for the y of a different point. Now, when x is 0, we're talking about the y-intercept. When y is 0, we're talking about the x-intercept. So we're going to get 2 points very quickly to graph. So when I let x equals 0, 2 times 0 is 0, all I'm left with is 3y equals 12, so y would be 4. That's the y-intercept. When I let y equals 0, 3 times 0 is 0, so I'm left with 2x equals 12, so x would be 6, and that's the x-intercept. So I think of the y-intercept as 0, 4, and the x-intercept as 6, 0. Boom, we're done. So when they're in these either form, it's very quickly to draw the equation, or draw the line. So let's look at the following system. This is the same system, by the way. So if we look at the top equation, I've highlighted it in red, y equals 2x minus 1. So we're going to start at negative 1 on the y-axis. I want to think of my slope as a fraction, 2 over 1. So from that y-intercept, negative 1, I'm going to go up 2 over 1, up 2 over 1. I can keep going as many times as you want. It only takes 2 points to make a line. But if they're close, I'm going to do more than just one extra point, mainly because if I'm drawing it on paper, it makes for a nicer line. Okay, and if you're taking a paper test, you want to have a little clear plastic ruler that you use to draw your lines. On the computer, it's a little easier. Okay, So now let's graph the second equation, which I've highlighted in green. Y equals negative x plus 2. So we're going to start at 2 on the y-axis. It's our y-intercept. And I'm going to visualize my slope as a fraction. I'm going to write negative 1 over 1. So I see it as a fraction. So I'm going to go, it's rise over run, so I'm going to go down 1 because it's negative, and then 1 to the right. Down 1, 1 to the right. Down 1, 1 to the right. And there's my second line. And where do they meet? They meet where the solution is, which is at 1, 1. So the solution to this system would be 1, 1, where the two lines meet. Here's another one. Now both of these equations are in standard form. So let's take the top one. I've highlighted in blue. So we're going to make a little XY table, put in our zeros, because we're going to look for the y-intercept and the x-intercept. So when x is 0, I end up with negative 3y equals 24, so I get an 8. And when y is 0, I get 4x equals negative 24, so x is negative 6. There's the y-intercept, there's the x-intercept, and I have my line. The bottom equation I've put in green, x plus y equals 1. So I make my little table with zeros. When x is 0, y is 1. When y is 0, x is 1. Plot those points, the y-intercept and the x-intercept. I draw my line. And where they meet is the solution. In this case, it's negative 3, 4. There are two instances when the solution is not a point or intersection, if the lines are parallel. So if I have two lines that are parallel, they never meet, therefore there's no solution. Because remember, the solution is where the two lines meet. We write it as a circle with a slash through it, or the null set, or we write it as curly braces with nothing in the middle, called the empty set. It means no solution. They could be the same line. In other words, here's my first line in red, and my second line is in green, which is on the exact same set of points. So they're the same line. There's an infinite number of solutions. Every point on the first line is also on the second line, so they intersect in lots of places, infinite number of solutions. And the way we actually write the solution is we write the set of all ordered pairs x, y such that, and then we put down one of the two equations, doesn't matter which one. So the curly braces at on the front and back end tell us the set of, the x, y tell us ordered pair, and then a vertical line means such that, and then we write the criteria, which is just one of the two equations. It doesn't matter which one we write. So let's review. How do I solve a system of two linear equations by graphing? I draw each line individually. How many solutions can I get when solving a system of two linear equations? I could get 0, 1, or an infinite number. In other words, 0, they are parallel. 1, they intersect. Or 2, they're the same line. Or I get an infinite number. They're the same line. So that could be parallel. 0, they could actually meet at a single point, which gives me one solution. Or they could be the same line, which gives me an infinite number of solutions. Classifying solutions. So let's talk about the types of solutions. Classify them. Consistent or inconsistent? What? Consistent or inconsistent? In other words, are the two lines consistent? Well, then there also are the two lines independent or dependent. So here's how you tell. And we also need to worry about conditional identity or contradiction. They're all three of these different types of classifications are related. Conditional. We'll start here. Conditional means I got a solution. A single point. An identity means they're the same line. And a contradiction means no solution. In other words, they're parallel. So conditional identity or contradiction are very straightforward. Did I get a solution? Conditional. Same thing works when you're solving equations. Did I get an answer? It's conditional. An identity means that they're the same line, infinite number of solutions. Contradiction means no solution, parallel lines. Consistent or inconsistent? If I got one or more solutions, that the more comes up with different types of things, not just lines, they're consistent. If I got no solution, they're inconsistent. Independent, dependent. To be independent, they must be different lines. Whether they meet or not doesn't matter. They're different lines. Dependent means they're the same line. I hope the presentation was helpful. Thumbs up, subscribe, comment. And if you have any problem types you'd like me to demonstrate, there's my address.